Welcome to a new video. In this video we're going to be making an inventory. Now for those following the Satisfactory tutorial, I'm going to try and explain how to implement this directly into the Satisfactory video at the same time because lots of people want to add that. And in the next part of that video series we'll probably be applying this inventory to our actual constructors, etc. So I'll go through that at the same time, but I wanted to make this separate from the series because some people might just want to make an inventory without having all the Satisfactory stuff behind it. So to start things off, we're just going to have a first person character template, and let's just create our project, call it inventory. We can put quality preset as scalable, we don't need too much, no need for starter content, and let's begin. Once the project's ready, we're going to start off by making a entirely new level because we're going to be placing items in the level, and due to how the default level works, it has the world partition system I think enabled by default and you can't disable it. So it has a tendency to unload assets for no reason and it's a bit buggy, so I just like to create a new level when we're doing stuff in the editor as well. So new level, basic, create it, and we'll just save it like that in, let's make a new folder, we'll call inventory, and we'll just call it new map, won't bother too much there. And let's get started. First thing we want is to open our inventory, and we'll make our two folders that we're going to need. We're going to need items, and we're going to need one for widgets. Now normally if we play this level, we should have the player character. Yeah, so we have the first person character, as you can see, with the hands. So we're going to use that, and we're just going to modify a actual component, and that will deal with everything. So we don't even need to touch the player character other than adding a actor component to it. So that's the first thing we're going to do. We're just going to make our actor component, set it on the player, and then we'll move on. So right click, blueprint class, and actor component. We'll call it AC inventory for actor component inventory. No, there's an N there. Inventory. So we can leave it here for now. We're going to go and open our first person blueprint right here. And we simply want to do add components, and we want to add our AC inventory. For those following the Satisfactory, we're going to take the Satisfactory character and do the exact same, just add the inventory here. File and save, close it, we don't need it anymore. Can go back to our inventory, and we're going to open our actual actor component here. Now the first thing we're going to want to do is we want to add a new input because we need an input to call this pause, this inventory. So for that we're going to go into inputs, input action, IA, and we'll call this inventory. We're going to make, well, we can right click on this and create an input mapping context, which we'll call IMC inventory as well. And inside of it, normally it should have set up our inventory. We just need to tell it that we'll use, well, let's say tab. We'll use tab for it. We'll save this asset, close it, and we're now going to have to add it here to our blueprint. So this is in the inventory, our actor component. We need to get player controller. We need to get a reference to the enhanced input, and we then want to call add context, or add mapping context, sorry. Drag this up, just align it, and the mapping context we're looking for is the inventory. So what this does, it will create our input, so we can say, now we can get our IA inventory, and we'll just test it with a print here on started. We'll put a hello, and let's just run it. If we now press tab, we get hello once, so make sure you put it on started and not triggered, because if we do it on triggered, if the player decides to hold it, he'll get too many messages, which will cause some issues. So we'll just leave it here. So with that, we have our inputs. Next, we can go ahead and start doing some of the logic for the inventory. So for the inventory, we need a few variables. First one is going to be the inventory itself. Now we need to set this up in a second because we don't have our items yet, so we'll do that first, but let's just get all the variables first. Then we have the max size. Now the max size is very simple, it's how many slots can you have in an inventory. by default here, we're going to put something like 3, just so that we can test that if the inventory is full, we don't pick any items up. So later we'll change it to something like 60, but for now we'll still leave it at 3. We also want another variable called allow duplicates. And allow duplicates is very simple. Do we want to be able to have 2 times the same item in a different stack? So in cases like Satisfactory, that's not the case. This will be disabled, which by default this will be enabled because by default we want duplicates. And the last one we need is a widget, which we don't have yet, which we're going to call as UMG inventory. And this is going to be the actual visuals that we have. So we're going to go and make our inventory and our UMG now. We won't do everything, but we'll just create them. So open our content browser. Inside of items, let's put it up here, we're going to need to make a structure. But before making the structure, we need to make our data asset. So we're going to start off with a blueprint class, which we'll call in look for all classes, and we're looking for primary data assets. Now for those following the Satisfactory tutorial, this is the exact one we've already made before for our items. We might just make a few changes to them here, so follow along and add the different variables we don't have in the one of that tutorial. So we'll call this DA items, and we'll open it up. And inside DA items, there's nothing. This is what it should look like. There's nothing here. We just want to add a few variables. Now, the first one is going to be a name, because the item needs to have a name. It'll be of type text. Then we want something called max stack, which will be an integer. Then we want image, which is going to be the texture 2D, which is going to be what we see on the icon in the actual inventory. Next, we want a static mesh, which is what we're going to see on the actual 3D model when we're picking it up or dropping it. So look for static mesh, and we want to specifically choose the basic one, not the actor, not the components, just static mesh. Grab that, compile and save. That does it here. We don't have anything else to do. We've just set up our base class for the items. Now what we want to do here is we can make a few items, but before that I want to make our structure, which is the inventory structure, let's say. So for the Satisfactory tutorial, we already did this. You don't need to touch it. Should be fine. So inside of blueprints, we're looking for structure, which we'll call st for structure inventory. And this is simply going to have 2 different parts. It's going to have the quantity, which is going to be an integer, and it's going to have the actual data asset. So call it that, and we're looking for DA underscore, that's items, sorry, not inventory, DA items. So you can save that. Now the reason we do it this way, because maybe not everybody's aware of this, but the reason we make our data, we make an actual structure in addition to our data asset, let's say, is because a data asset is unique. Let's say if once we have one, I'll just make one real quick. So go into our right click here and search for data assets. I'm going to make it based on our DA items, and we'll just call it DA, let's call it cube. That'll be our first item. So in here we can set it to cube. We can set a max stack of, let's say, 100. And for image, we're just going to go with the icon green, and we're going to choose a chamfer cube. So the reason we have this for the quantity instead of having it here is because if we have multiple times the same item, then it will still have the same data assets. Meaning if we change, like if we had quantity here, if we change quantity in the data asset, it will change it for all the data assets. Because in essence, let's say the data asset is the blueprint of the actual items themselves. So if you change the blueprint, it changes it for all of the items, which is why we use this to store things that can change. So that's why we have a structure here instead of just using using it in here. So with that, we can now change our inventory to what we actually need, which is an integer in a map with our actual structure. So st underscore inventory. And the reason we use a map is because if a player has, for instance, let's say on 0 he has a cube, and that makes sense, it's fine, it's not a problem. But if we have another one, so let's say we have a second point, it may be on 1, which would work just fine if we had an array. But if, for instance, the player has something on index on the 6th slot, then an array can't deal with that. Unless we were to add something in here as well, but that makes this more complicated for nothing, when we can just use a map for that. So let's just clear this out. And now we can get into, actually we need our widget here. Let's do that first. So we can go into our widget folder, right click, and we're looking for user interface, widget blueprint. Select the common one here, and we'll call it UMG underscore inventory. Now the UMG inventory is not going to be probably what you think it is. We're going to do most of the logic for our actual inventory inside something we'll call UMG grid. And the reason we do this is so that if we have a scenario where we don't want to have just the inventory, let's say there's a chest, we also want logic to be able to be used easily for the chest, not have to remake a new inventory. We'll just use a grid UMG, which we can place anywhere and give the information it needs. So first we'll set this up and it'll be more clear once we actually start everything. So we'll start with a scale box, which will add then a canvas panel to it. And what this does is that it scales up to the actual screen instead of just to 1980 by 1920 by 180. Sorry. Inside of this, we want to add a blur. We're going to add a background blur just to make it easy to see. We're going to make it full, so select the last anchor in the bottom right, and make sure you set all the offsets to 0, meaning it will cover the whole screen. We can set it strength to something like 3, I think. That way we can clearly see the difference, but it's not overwhelming either. Next we want to add a canvas panel, and this canvas panel we're going to put in the middle. So we're going to center it, and we're going to make its alignment 0.5 and 0.5. Set its position to 0 and 0, and size to 1200 by 800. Which is pretty big. But what we'll do is we'll add another image in the back here. Once again, and this is going to be fill as well. So select once again the bottom right. 0, 0, 0, 0 on the offsets. Oh wait, sorry, I'm on the wrong thing here. We're supposed to be talking about the image, not the canvas. So put that in full screen as well. And we'll set it to a dark grayish. And so for now that does it here. We don't have anything set up because we don't have our grid yet. But what we'll do first is we'll test if we can open and close our inventory. So let's do that now. So back in our AC inventory, we now have our actual UMG inventory. So let's change the reference to that. Sorry, for some reason, inventory. Yeah, UMG inventory, select it, compile and save. And so for inventory, we're going to open that. So let's just give it a bit of space. Now, the first thing we want to do is we want to make sure if this exists already. So we're going to convert it to a validated get on started. Now on not valid, it means we do not have one yet. So we're going to create a widget. And the widget we're going to create is our UMG inventory. And what we'll do, simply promote this to a variable. Let's put that here. Next, we want to add it to viewport, or the player won't be able to see it, which is pretty useless. And to finish things off, we need to change the input mode for the player. So get a reference to our player controller here. We want to call show mouse cursor to true. And we also want to set input mode game and UI. By default, it's just game. We want it to be game and UI. Here we go. And on the other hand, if it is valid, we're going to do the opposite pretty much. We're going to get this again. We can copy that. So we want to get our show mouse cursor here. And this time we want to hide it because we're going back to the normal game mode. We want to call set input mode game only. and we'll flush the inputs. There we go. Just drag that here. And to finish off, we need to change this back to what it was before, so non-existent. So we'll remove from parent, which is in essence saying destroy actor, same thing. But we also need to make sure we set this to empty. So with that, we can compile and save. And normally, if we press tab, we have our widget that appears, and we can press it again and it will open and close. Next on the list, what we'll do is we will set up the functions. First, we'll have a pickup item, which is going to take in actually something that we haven't made yet, because we need an actual physical version of this. So let's actually do that first before I forget. So we want to do right click, blueprint class, actor. We'll call it a_item. And very simply, what it's going to take is it's going to need its structure. So this is the st underscore, well, sorry, we'll just call it structure. And it's of type st inventory. And with this, we can tell it what it's supposed to be, how many items there are. So we want this to be exposed on spawn and instance editable. That way, if we need to spawn one, we can just do it immediately. So with that, we can then tell it in event begin play that we want to take the structure and we'll be applying it to things here. So what we need for that is we actually need a visual, so a static mesh. We'll leave it here. We won't attach the default route. That way we can move it if we ever need to. But we also want to add a sphere. So the sphere is just how we're going to use it to detect if the player walks over it. We'll say, well, he can pick the item up. It'll pick it up for him or not if he doesn't have the place. So for those using the Satisfactory tutorial, we already set up something like this where we pick up the item with a line trace. You just use the line trace instead of this once we do the pickup system. So we want to break this. And we want to tell it, also obviously for those who are doing the Satisfactory tutorial, they already have the item. They don't need to do any of this, we already did it. So we do is valid, because if the item asset of the data asset isn't valid itself, then we're just going to delete it because we shouldn't have an item with no data assets. We'll just destroy actor. So hide those. If we do, we want to get static mesh from our actual data asset. And we will tell our static mesh here to set itself to this value there. Go. That does it for the start. Next, all we need to simply do is in our sphere, we want to make sure that we overlap everything. So we're going to put this as custom. Actually, let me just double check that. Yeah, so we want to ignore all of these, the trace channels, we don't care. But so we'll actually put overlap all, but we'll just move the trace channels to ignore because we don't care about them. So with that, we want to select our sphere, go all the way to the bottom, and we're looking for begin overlap. Now, to determine whether our actor is allowed to overlap, so if let's say a clone or anything was supposed to pass over it, be any cube, what we can do, instead of doing a cast to our first person character, which would cause this logic to only work if we have the FPS character, we can say get components by class. And what this does is it will scan through the actor and look for a specific component. So we're looking specifically for AC inventory. And so we know if this is valid, that we have a valid target and that we can call our inventory functions. So we can call this here pickup item. Now for pickup item, we're going to have some modifications that we'll do right now. We need an input and an output. The input is going to be the item. So it's going to be of type A item. So let's close that. And for the return, we're simply going to have a return value, which is going to be a boolean whether we succeeded in picking it up or not. And when we say succeed, we mean, or I mean, the item was fully consumed. Because if let's say we have a max stack of 100 and we have 95 already in the inventory and we pick up 7, then there's 2 left. So we only say true here if it is completely gone. So that's what we'll be setting up after. In a item, what we'll do is we'll put a branch and say if this is true, there we go, we can destroy the actor, because that means it's being completely consumed and we don't need to worry about it anymore. And with that, we have finished our item. No need to touch it anymore. Actually, no, sorry. We need to tell the item to be self, otherwise it won't know what we're talking about. So we can compile and save, close the item. We don't need it anymore. Actually, we can run a test first. We have an item here. We'll place it there. I'll actually add a start for the player. And let's just rotate it towards the item. So we have our start here. And we need to give it a structure, because currently right now it will just destroy itself because it doesn't have a structure. So we'll say 50, and we'll say that you are a cube, because that's the only data asset we've set up. So now if we play, as you can see, the chamfer cube appears. Obviously, we can't do anything with it. And also, yes, one other thing we'll do is we will tell the item, the static mesh, to just ignore everything. We're not going to have it have any collision. Because it's an item, we want to just be able to pass over it without any worries. So even if it's strange, you can change this. It's not mandatory. Just make sure that the collision for this is bigger than the actual item itself. So we can actually make that a bit bigger. We'll make the size of the sphere something like 100. So now it's a lot bigger. We can also, while we're at it, we'll say, because it's by default hidden in game, we'll just disable that. So now we can actually see our sphere. So once we overlap this, it'll let our character know. If we can test it here, print, it's going to tell us that we overlap it. Yep. So if we keep going over it, now obviously this will happen every time, but we'll delete it if it succeeds or if it doesn't. Actually, I just remembered we forgot something. I forgot one last thing. We need to actually add a function here to modify the quantity if we need to. So let's just make that very quickly. It's a really simple function. We'll call it modify quantity. And this function is simply going to take in a variable of type integer, which is going to be the new quantity. New quantity. No, there's another T there as well. It's going to be an integer. And we simply want to get our structure here. And we'll call set members, which allows us to modify just one specific value in the function, in the structure, sorry. And we need to select our quantity, which will make it appear here, and we'll set it to new quantity. And that'll do it. That's all we need to do here. We can now finally close the item. Next, what we need to do is we'll do the pickup function and the other functions that we need alongside to complete this. So we'll need one function called isKeyFull. It'll take one input of type key, which will be an integer, and it will return whether that's true. So return value true, and we also want to return an integer, which will be the remaining quantity, because we need that later for when we decide how much we can add to the item, or to the stack, sorry. Another function we'll call item added. So item added. And this very simply is going to take in a slot, or more like we'll say slot key, and then slot value. So this is referring to the key and the value of the actual inventory. So this will be of type st inventory. And we're simply going to get our reference here and say add. And this is all it's going to do. It's very simple. It's mainly going to be used for dispatching an event from our inventory here to here, so that we can update our inventory, our actual inventory, based on the one we'll have here later. Next, we need a function called item dropped. So for drop item, what we'll be doing, because by our system we set up, we pick up items by overlapping them. When we drop an item, we're going to drop it a bit in front, like quite a bit in front, so that we don't constantly repick it up and have an infinite loop. So to do that, because our actor component isn't actually physically present in the level, we need to get our owner. And with our owner, we'll do a get forward actor. So get forward vector here. and we want to get actor location, and we're just going to use this times 300 here so that we can get a distance in front. So let's just get a float here, 300, and we'll be adding this to the start location. And the reason we do this is that we move forwards but based on the center of the character, and we'll then look down to see if we can drop an item there. Now this is a very simple way, because if we drop an item, let's say over an edge, it'll just appear in the middle of nowhere, which we wouldn't really want, but because it's a simple tutorial on inventory, we're not going to bother too much with this. We then want to call box trace by channel. Just going to go right here. Yeah, we also need to obviously add a reference to the item structure in the input, sorry. So this is the item dropped. And for the end, so for the start we have this. For the end we're going to say minus 500. That's going to go into the end, so that will go down pretty much. We want to say 15, 15 and 15. Just keep it pretty big so it just finds anything close. And for the, we need an actor to ignore because we would hit the player character here in some scenarios, so we don't want that. So we'll say make array, and we'll tell it to ignore owner. And the last thing we need to do is if we hit something, so we'll do it that if we hit something we drop it, if we don't then we don't drop it. We break the hit result, and we want to on true spawn actor from class. We will swap that to the impact point, and we will say that the class is our item. There we go. And that should make our structure appear, which is the one that we have for the item dropped, because the item that we drop is obviously going to be appearing outside. And with that we finished our item drop. Sorry, I have the wrong get owner. So we need to say get owner, but we're looking for the components one, because we're not looking at self and actor, we're looking at self a components. The last item we need is item removed. And this is pretty much the same as what we did with the add, but for the remove we only need a key. So we just get the key, which is an integer, and we say inventory remove, and we select the key. Plug this in, and that will be done. Now one thing I just need to make sure is key full is, yeah, it should be a pure. And we will get into that right now. So is key pure is the first one we'll do, because we've already finished the remove, we finished the drop, and we finished the add. So we're going to do is key full because it's the last one we need before making the pickup item. So just so we understand what it's for, pretty much it's just going to check whether the inventory either has a slot available there or has a empty slot there, as in an item isn't fully stacked. So the first thing we want to do is we're going to get our inventory. We're going to say find. I'm going to look for the key. So key will be at the bottom here. And if we find the key, we'll do the false first. If we don't find the key, then that means that the slot is available. So we'll simply return true, that the slot is available. We'll turn false because the key isn't full. And what we'll put as the remainder is -1, which will indicate to us in the pickup that, well, hey, there's completely spaced, there's nothing at all there, so we'll create a new item for it, a new slot, let's say. So we'll do that here. On the other hand, we'll have to break our inventory, and we're going to need two things. First, we're going to need our max stack, which, there we go. And we're also going to need our quantity, which we have here, and we'll say minus. And what we want to do here is we want to subtract the the quantity from the max stack. So make sure you do it in this order specifically, otherwise it won't work. And if this is double equal to 0, or, because we're also going to set up max stack here, if you're equal to 0, that means there is no cap and we can have as many items as we want. This will return here. Sorry, so I got this wrong. This needs to be an and this needs to be a, if you're different from 0, sorry, like that please. If you're different from 0 and this is double equal to 0, that means that there's no more space. If this is equal to 0, that becomes false, and that becomes false, so it means we do have space. Now the remaining will always be based on the subtraction here. So compile and save, and now we'll do it for our isKey full. And so we can close that, and now we're going to work on our pickup item here. So for pickup item, the first thing we want to do is we're going to get our structure here from our item, and we're going to get that information. So we're going to break it, and we're going to save this as quantity in. So L quantity in. Go, and then we'll save this as promote to local, and it will be L data assets. I'll put data asset in as well, even though it's not going to change much. There we go. Just line this up with that. So next what we need is we're going to add a while loop. And the reason we do it this way is because we want to pick up items always to be at the closest to the beginning of the actual slots. If in the event that there is no space in their one stack, they move to the next one. So to get that, we need the quantity in. I'm going to check, as long as you're superior to 0, we'll keep going. But we can't just do that, because if we reach the end of the loop, the end of the inventory, and it is full, we'll just keep going forever. So we need to add a second condition to that, which is we're going to create a new variable here, which will be called L index. And L index is going to be of type integer. And what we'll do is we'll increment this as we go when we check the next slot. And if ever it is inferior to max size, so our maximum slots, then we can keep going. But if it goes above, then we stop the loop as well, because both of these conditions need to be true to keep going. So inside of the loop, we'll start with a sequence, and on the bottom of the sequence, we will increment our index. Pretty simple. Just every time we're done, we move on to the next value in our inventory. Now, as I mentioned, even though this isn't, our inventory can do any numbers, we still want to go through it 0 to 60 in that order, because those are all the slots that can exist, but they may not be the only ones that exist. So we stick with the map. So with the index, we need to check whether our key is full. It's the first thing we need. And what we'll check is if it's true, if it's full, so meaning there's no more space for anything else, we need to actually check if the item already exists. So the reason we do this is because of our duplicate boolean here. So we have a branch, an extra branch here if we found it, right? And what we'll look for is we'll get our inventory, we'll look for the index, so get index. Now the reason we know we can do this and we don't have to worry about it existing is because we've already found it here, otherwise it couldn't be full. So what we do is we are going to break this here so we can split it, and we're going to check whether our data in is equal to our data that we already have in that slot. If it is, that means that we have a stack already full of item that we're trying to add. So that means if we don't accept duplicates, we can't pick this item up. So we let it know. So to do that, we need another variable, which we'll call L found same item. This will be a boolean, and we're going to set it to true here, and we never set it to false. It's just that if it happens, we need to know. Next, on false here, we're going to promote our remaining to a variable so we can check it. So this will be L remaining, and attach it to false. Now if it is double equal to -1, that means that there is a completely empty slot and we can immediately put the item there as long as we have the specific condition. So we're not going to do this immediately. You would be able to think, for instance, usually you'd think, well, we found an empty slot, right? We can just add it. But because of the nature of an inventory, we have to go through every slot one by one anyway, because in the event that we find another slot that has space for the same item, then we need to put it there. We don't want to create a new slot every time just because we have an item at the end of the list. So we need to just save this key. So what we'll do is we need to create another variable here. So we'll say double equal, and we're just going to grab this here for a second. Promote this to a variable, and it will equal L empty key. Now, one thing we do need to do for empty key, just to be sure, we need to set you by default to -1. And the reason for that is because -1 is an invalid index, or at least we won't be using -1 as an index. So if it's double equal to -1, then we can't do this. Sorry, no. If it's double equal to -1, it means we haven't set an empty key yet. But if we have, we want to set empty key to the actual index. So what this will do is at the end, it will save this value to the earliest slot we found available, and it will put it in that slot. On the other hand, if we're not equal to -1, we need to call our remaining here. Actually, no, we don't need the remaining here. What we need is this again. We'll copy that. Actually, we'll copy all of that, because we need to check whether because currently now this means the slot is completely empty. This means there's some place left. So if there's some place left, we need to know whether first we're dealing with the same item. Otherwise, we can't really add it. So we're going to need a reference to our quantity as well here. So we'll reroute it. And what we want to do is we're going to add to this. We're going to add, because how add works is it will update as well instead of just deleting if the key already exists. So the key being L index right here, the structure we can split, and the data asset is a data asset in because we've just checked that they're equal. So we know they're equal, attach it in, and for the quantity we need to add what we previously had to what we currently have. So we'll just add another reroute here. But for the plus on the other side, we need to add a clamp, because in the event that this plus this is superior to what we can take, then we need to be careful. So we have quantity in here as the value. That's the value we have. That's how much we want to put in. But we have L remaining for how much space we actually have left. So what it will do is it will stop it from ever going higher than what we can add to it. So I'm just realign these. And so to do that, once this is done, this is the only scenario where we need to modify our quantity in. So we'll do that. We modify quantity in, and we say the same thing there. We take quantity in minus the remaining. So both of those, there we go. And we need to clamp these again. So clamp, there we go. And the clamp we need is simply so the reason we want this is just to avoid negative values. Very simply, we just don't want to have a negative quantity at the end. And then because we found the same item, we do this because there is a scenario where there's still some quantity left. So we need to inform it that we have found the item. So what we do here on completed, because this is where all the logic actually happens, on completed what we'll do is we will say if quantity in is double equal to 0, then we can simply return true, because that means that we no longer need the item, so we can just delete it straight away. Because all of the adding is done here. We modify it here. Here we save the key. And if we save the key, we're not actually modifying the quantity at any point because it's empty, meaning that we can store 100% of it in here. So first we need to check obviously if it's been consumed before. If it has, we don't need to use the empty key, so we ignore it. If the item has already been found and we don't allow duplicates, so not non-equal, but not Boolean. If these two are true, so and, if these two are both true, then that means that we just simply delete it, or at least we modify the quantity. So here, modify, sorry, I need a reference to our item. So get item, sorry. So this is the item that we have at the parameter, sorry. We want to modify its quantity to our quantity in, which is the quantity remaining. Because this will check pretty much if we don't allow duplicates, then it will only modify the quantity that was allowed for the duplicate. Now, if it's already gone, it doesn't matter because we used everything anyway, accepting this rule. So here we return true, return false because we didn't manage to destroy everything. If we have a branch here, one more, if our empty key is different from -1, then that means that we allow, or at least that we found an empty slot to put this into. And in that case, we simply need to say with our inventory add right here. We can split this. We can get our quantity in, we can get our data asset in, and we can get our empty key. Empty key going into key, quantity in and quantity, and like that. Data asset the same. And here we can return true because whatever the item could be, it's maxed out of its max stack, and we have an entire stack available. So we don't need to bother. If that is not true, then we just do return false. We can compile and save, and now normally if we walk over our item, it'll disappear because we have enough space. So to confirm that this is working correctly, we can go ahead and duplicate our cube, and we'll say cylinder. We'll add another one of type, let's say cone. Now let's just modify these. So cone, there we go. Sorry, no, that's the cylinder. There it is. We'll put edit to cylinder. Close that. Put cone here. So that's our 3 items. We're going to add a 4th just so we can check whether the limits do exist. And what should we have this? We'll have this be a plane. No, maybe not a plane. We'll just put a normal cube. Sorry, that doesn't work. We'll put a sphere. That way it's easier. So for the sphere, we just look for a sphere. Anyone will do. Preferably not one that's too big, so we'll say the editor one. I think the editor one is a bit big, but it doesn't matter. So now we have all 3 of these. We're just going to move them a bit apart so we can run the tests and change this one to sphere, change the 3rd one to cone, and change the 2nd one to cylinder. If we play, we have our cone, we have our sphere, we have our cylinder, and our cube. If we pick 2 of them up, that's okay. If we pick a 3rd, that's fine, but a 4th, we can't pick up because we have no more space in the inventory. Now what we can do to make sure of this, to just double check, we can expose this variable here, compile and save. And if we run through it again, if we go and press F8 to get out of the game, we can go down to our AC inventory here. We can open our inventory, and we can see that the first one we picked up was a cube. There was 50 of them. We picked up 50 of the cylinder, and there's right here we have 50 again, and you as well 50, but we can only pick up another one, and it won't let us pick up a 3rd. Let's check again. It does have 3 normally if this is going well. We do indeed have 3 items. We just picked up a cone as well, and so it does seem to be working. Now, one more test we should do, just to make sure, is, if I'm correct, I'm just checking something here. If the item here, so let me just open our data cube. So there's a bit of an issue because we're supposed to be able to pick up 100. Sorry, no, that's wrong. I'm getting that wrong. This is 50. I'm just saying the max. So if we pick up this one, right, and we change its quantity to 70, meaning if we pick it up, it's fine. If we pick up these 2 first, it's not a problem. It'll be added to one another. So we should have 120, meaning we have 50 here, and here we should have another 50, which would do 2 items for us. So if we select our player again, go down to our inventory, we have 2 slots. The 2 slots are the same, one with 20, one with 100, same item, but they just stack on top of each other. Or another check we can do, see if everything's working. We pick up the 50, we pick up another item, which will take up slot 2, and we pick up this, which should be slot 3. So this is just to see if it's sorting them correctly. So it does seem to be working. We have our slot 0, our cube, which is the first thing we picked up. It's stacked fully because we added the items to it. Then we have our cylinder, same thing. And finally we have our cube, which was added at the end, and it can only take 2. Now, if things working correctly, we cannot pick this up. We cannot pick this up because they don't qualify. There's not enough space in the inventory. And that should be everything as far as the picking up goes. So next is the actual widgets. Okay, so let's get into the actual widgets. So the first thing we need to do is we need to make our new widgets. So for the new widgets, because we need a few more, we're going to need first a widget which is going to be the actual grid. It's going to be the complete inventory all in one spot. And this is going to be called UMG we'll just call it inv for inventory grid. Then we need another one which we'll call UMG, or once again use widget, sorry, UMG, and this will be item. And then we're going to need one last one, which is going to be a use widget again, UMG underscore inv for inventory, and this is slot. So we're going to start with the slot. Actually, maybe we'll start with the inventory first, because this is a bit complicated because there's a lot of back and forth references with event dispatchers to make things easier to manage. So actually, before we go any further, actually now that I think about it, in the inventory itself, we do have some of those. So we're going to do that first. So the first thing we can do actually in our inventory here, our UMG inventory, we can now add our grid. So let's go and get our inventory grid, place it in the canvas panel in the center. And what we're going to do with it, we're going to center it, and we're going to put it at 100, 100, 100, and 100. And what this will do is, because we're going to be using 100 units, it's going to give us a grid of 10 by 6. So we're going to have 60 item slots. So we'll change this back here to 60, because it's going to use this information to actually make the grid. So what we need in our basic inventory, in our inventory UMG here, we're going to create a few variables. The first one is going to be the widget inventory, which is because this is our, let's say, our main inventory widget. We need to know, once the player calls it, what's already in the inventory. So this is going to be of type integer, and it's going to be a map, like pretty much exactly like what we have in our AC inventory. So it's going to be a type structure inventory. Compile, save. We want to make sure that this is exposed on spawn. Then we want to have another one which will duplicate here, because we need to have it exposed on spawn as well, which is going to be the widget size, which is just going to be an integer. And finally, do we allow duplicates? Duplicates allowed. There we go. And duplicates allowed is a boolean, also exposed on spawn. And we want you to be true by default, even though it's going to be set true by default anyway. Next, we have 3 event dispatchers we're going to make. First one is item added. Second one is item dropped. And the third one is item removed. So these are kind of the 3 conditions we have here: added, dropped, and removed. Compile, and we need to set up their actual variables. So for the item added, we need to know the inputs. The first one is the key, so get that key. Second one is the slot value, so slot value, and that is going to be of type st underscore inventory. Here we go. Compile. Next, we need the dropped. So dropped is going to be just the structure. So we'll call it structure. And finally, for removed, we simply need the integer, we need the key. So key removed. Compile and save. And we're going to have to go back into our inventory here for a second. Back in our event graph, where we make it appear, we need to have these 3 visible. So if these 3 new, these 3 new inputs aren't there, make sure to right click and refresh the nodes that they do appear. Simply connect our 3 different variables here into it, and that'll set it all up. Now we need to also bind our event dispatchers here. So we're going to do that right here as well. Because we have a reference to our as UMG, we can do it here. We want to bind events, and we're looking for item added. Then we want to bind event again, item dropped, and bind the last event, which is removed. Now for connecting these, we'll just detach that. For bind event added, we'll say create event, and it's going to be attached to here. So look for item added, connect it. For item dropped, same thing, we want to create event, and we have our item dropped here. And finally, for the last one, create event, we have item removed. Now, if anybody's wondering why they're already appearing and they have similar names, it's simply because the reference that we're getting, or at least how we're referencing these, is it's based on the actual inputs. And because these have the exact same inputs as what we made here, they're the only ones that appear in the actual list. If you don't have the functions, you can also just create a maximum function, which will do the same thing. We just did it in the opposite order. So we just need to change this back to item added, compile and save. And what this will do, for those who don't know what event dispatchers do, it's whenever we call this here by saying call, any information we give it will call the function here. So it allows us to avoid having to add a reference back to the actor component. Just simply referencing the functions instead makes it a lot easier to use. So let's remove that. We don't need event tick, we don't need event construct, we just need event construct, sorry. For the next part, we're not going to do anything here first because the inventory itself does nothing alone. We're just going to set it up so that it works with our grid that we just made. So let's go to that. So our invent grid here is simply going to take in one thing. It's going to be a grid, and we're looking for a grid panel, not a uniform one, just a grid panel. Attach it here, and that will be done for our grid. That's all we need to do in the actual designer. Now we have to go to the graph where it gets a bit more complicated. So inside of the graph, we need 2 event dispatchers this time. We'll be calling them invent, once again, so inv, item removed, and another one we will call inv item added. So just like with the other one, item removed takes in an integer. So type or name key. Item removed takes the key and it also takes the value. So this is st underscore and that is inventory. There we go. And this is the value. Compile and save. For the actual variables, we'll do that here as well. Variables, we have the grid size. So that is going to be an integer. We have a max row, which is something else we need to do. Now, this is just because I made a macro that makes things easier for organizing the grid. So I'll be making that for you guys as well. Next, we need a grid inventory. Now, the grid inventory is very similar to this, but the difference is we're not going to be referencing our our structures. We're going to be referencing the actual widgets themselves. So we keep our integer, but we make it a map, and this time we're going to be using item. So umg item. Only the ones that are actually visible. So the umg item or umg inventory slot is what will be visible behind, but the umg item is what we need here because it's what we'll be able to click on. Then we want to have duplicates allowed. Once again, boolean. And that'll do it here. Actually, we need to make our grid panel a variable. So if it's not a variable, it won't appear here, and we actually need it. One last thing we want to do is we want to make max row visible. And the reason we do this is so that if we have it appear here, so I have our inventory here, we can tell it exactly what we want it to be, no matter which inventory. So let's say we have another inventory later in a game. We just move it like this, and that divides, let's say, the distance by 2, or we can no longer have a 10 row. It needs to be 5, so we can inform it with our variable here. Now it's not visible, we haven't compiled. If we compile that and we click it, it should be, there we go, max row, and we're going to make it by default 10. So let's just do that here. 10, compile and save. For event graph, we don't need to do anything. Now we should be able to call all we need to do from here. So one of the advantages of event dispatchers when we're talking about actually using them like this is they appear here. So what this allows us to do is, like any other function, we can just call them right here, and it will allow us to use them however we need in this specific window. So this also works obviously for any kind of actor. Do the same thing here, it'd work exactly the same. So what we want to do is we want to use these to call the more detailed, or the ones that are directly accessing our AC inventory. So to do that, very simply, we're going to start with our widget here, and we're going to remove the item, because that's what we want to do. That means the item has been removed from our proper widgets, as in it's no longer actually visible in our grid that we're using for the inventory. So we're going to remove it from our parent grid. And at the same time, we'll be calling call item removed, which is going to reference our inventory here and tell it to remove it as well. Next, we do the same thing for the add. So we're going to add an item here. There we go. Attach our little variables here. Just move it a bit down so it's easier to read. And we do the same thing with our item added. It's right here, call. And we need to plug in our keys and plug in the values. And that's all we need to do with these. This will pretty much be called throughout the logic when we drop it in certain areas. We'll do that. So we can now do the event graph. Sorry, not the event graph, the actual construct. So where we're going to inform it how to act. We're missing one function, but we can do most of it for now. So we want to get a reference to our UMG inventory grid. We're going to call grid size. Sorry, not get, we want to set grid size. Let's just align these up. Sorry, align them. There we go. We're then going to call set duplicates allowed. Same thing. And the last thing we need is something we don't have yet, but it's a function we're going to set up in a second. So let's just attach widget size here. Why is it widget? No, sorry, this should be inventory size. And finally, duplicates allowed or not. There we go. And for this, for the actual widget inventory, we're going to be doing it a bit after. But for now, we don't have the function, so we'll just wait a second. So inside of inventory grid, right here, we're going to make some functions. Because on the begin play, we don't do anything. We don't need any of these. We can get rid of all of that. But we do need a few functions. So the first function is going to be called create grid background. And the reason we need a background is one, visually, but we also want to use it as buttons, let's say, of sorts, so that we know where to drop items and any other thing like that. Next, we want a function called add item to grid, which, just like the name, just like it would lead you to believe, we're going to take in a key and a value, and that's going to create an item for us in here. So just key, value, make sure this is structure. Next, we're going to do one other variable that we don't have anywhere else, one other function, sorry, that we don't have anywhere else, which is the item stack split. And so what this takes in is it's only going to need the actual widget reference here. So the widget we're referencing is the UMG item. Go get that, and we will say item split. So compile and save. Next one we can duplicate from add item is item removed. And item removed just takes the key. And the last one is we want to have a function called item quantity modified. Go. And actually, sorry, let me just duplicate this because it's the exact same, but it just can't do the same thing. So item quantity modified. Go. On save. And what this will do, because we can do this one right now, it's going to call this function and it's just going to connect like this. Now the reason we don't have it, we don't do it with this, is because this is going to have a bit more logic than just that, so we needed it separate. So now that we have all our functions, we can go back to our UMG inventory. We can actually call them all. So for the grid, what we want to do is we want to say, we want to create our background grid here. So we'll call that like this. Actually, I'll just call it again because it's a bit of a mess otherwise. There we go. And finally, what we need to do is we need to make our actual already existing items appear. So to do that, we need keys like this, and we're going to say for each loop. And what we'll do with our inventory grid here, we're going to say add item. And because we have all that information available from our actual widget, we'll say find. We're going to find based on the key, plug it into there, and the key goes into there. And right now we have our items will spawn. Obviously now they won't do anything because this function does nothing yet. First thing we'll do is we'll make our grid, so we actually have something we can see once we go and, oh, we have an error. Let's see that. Why do we have an error? Oh yeah, sorry, that's because we renamed it. So let's just reattach that. So now if we currently play, nothing will happen because we don't tell it to do anything. But we're going to make it so that we can see our background, or at least our grid. So let's do that first. So for create background grid, very simply, we're going to start with a for loop. And we're going to go through our size, so our actual grid size here. And we're going to say -1, because obviously we start at 1, even if the grid is 30, we start at 0 and go to 29. First, what we want to do is we need to make the macro that I'm using. What the macro takes is we take one input, which is going to be the index, let's say. Then we take in our max row, which is this. So we'll just reroute it here. And with these, what we do is we divide one by the other. Okay, so we reroute this right here. And we're going to multiply it by our variable here. So we'll then subtract like this from our child count, let's call it. And this will return the column. Let's reroute here. And this will return the row. So I'm going to have to reroute again, and normally if we collapse this, sorry, yeah, so that'll work, but we're going to collapse it to a macro, not to a, so collapse to macro, and this will be called determine grid location. So let's just go back through it, double check, max row here, let's open it. The first input is child count. The second input is max per row. The output number 1 is row, and the second one is column. So I'll try and go through it again just so everything's clear on how it works and why it works that way. So just give me a second to just reorganize all of this. Okay, so very simply to go through it as easy as possible. We start off with our child count and we divide it by our max row. So let's assume this is 10. So if there's 10 and the child count is 5, that means it's the 5th and it needs to be on the first row. So the reason what we do here is this will inform us then of what row that is. So this has gone in the wrong way. So with this, if it's 5 divided by 10, we get 0.5, but that should, so what we can do for safety actually here, we'll do that. We'll take our child count, we will convert it to a float, and we will use that here instead. And because of that, it will turn here an actual, what's it called? A float. We need to floor it. And the reason we floor it is because we want it to make sure that it goes down. So unless it's above the value, so in the case where you divide by 0. Let's say we have 9 out of 10, then that's still row 0, but the division will give us 0.9, which could lead us to have 1, but we don't want it to be 1, we want it to be 0 because it hasn't gone over it yet. So we floor the value to make sure that doesn't happen, and that will give us which row we're currently on. So like that. Next, what we need is we need to get the column. So to get that, we have our value here, so we know currently which row we're on. So to know that, so with the row, sorry, we can know how many we are. So we need to remember that if we have, let's say 10 per row, and we have on floor 1, sorry, not on floor 1, but on floor 2, let's say, then we have 2 times max per row, which will give us, let's say 20, and then we need to simply remove the child count from it, which will give us the column that we're on, like this, and that will be plugged into our column. Okay, so with that, we finished our macro, and we can get to our actual grid here. So with the grid, what we need to do is we're going to start by creating a widget. And this widget we're going to create is the actual slot. So for the slot, we actually need to save the key, but for now we don't have it. It's not too important. We have a few macros to add, but we'll start off by simply making them visible. So we need our grid. We're going to say add child to grid. And if we plug this all in with our in row and our column with what we made, the content is our new widget. We'll line this up. And with that, we have created our grid. Right now, this will create our grid. If we normally go and press tab, it did create our grid. I just forgot something. The item inventory slot is invisible. We don't have anything yet, so we don't see anything. So let's just give it a bit of a visual so that we know exactly what we're looking at. So the visual I went with is we are going to make a canvas panel because we can't do anything without a canvas panel. And we're going to use an image. Sorry, an image. And the image we'll use is going to be invisible to make it transparent, and we want it to be 100 by 100. So the reason we need this is just so we can click, because otherwise it won't detect that we're actually clicking on the item. So we're now going to add our grid panels, or a grid pattern, let's say. It's going to be very simple. It's going to be 100 by 5. Sorry, by 2 I think I used. No, I even used 100 by 1, okay. Sorry, by 1. And now we simply want to duplicate this 4 times. And the second one is going to be add 100 on the Y. And because now currently we can see it goes under because it's 101, we tell its alignment on the Y to be 1. So that will make it inside of the actual 100 by 100 grid. Same for this. We want to put it at 0, 0. And we want it to be 1 by 100, which will make it go exactly there as well. Same trick here. This time 100 on the X, 0 on the Y. And we want it to be 1 by 100, and we need to make sure the alignment is 1 on the X, so that it appears in the circle again, in the grid, sorry. So now if we play, press tab, we have our grid, and it works exactly as we want it to. If we go and change our inventory max size here to something like, let's say 55, we should have the grid that stops midway. So just like that. So as we can see, that's exactly what we want. We have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So that's 50 and 55. So working as intended. So let's compile here. Next, what we'll do is we will finish up this so that we can spawn it 100% correctly. Because we need a few variables, not too much, just a bit. We need a variable we'll call the key. It's going to be an integer, and this is so that if we drop an item on it, we know where that item is located without having to search through the whole grid again. Make sure it's exposed on spawn, sorry, before I forget. We can also select all 3 of these, or all 5 of them, sorry, and make them non-variable because we don't need to touch them whatsoever. As far as things go here, there's not much to do except what we're going to be doing later, which we'll set up for the movement, but we're not going to do that yet, do everything else first. So with that, we are finished with our inventory slot for now. We'll be modifying it a bit later. Next, let's do our item, our actual visual item. So for the item, we're going to follow pretty much something very similar. I'm going to start with a canvas panel. Actually, maybe we can just skip that and do a size box directly. I'm just going to try this. So if we add a size box, yeah, size box should work as well. So we want to set the size box to a minimum, to a width override of 100 by 100, because we want it to be the same size as the slots themselves. And we're going to start off by adding another canvas panel inside of it, because otherwise we can't do anything inside. So what we want to do is we'll be adding an image. This is going to be our image background. So this is that no matter what we hit the items. Now I just want to modify this to be a custom size. So custom, we're going to put 100 by 100. So this is what it will look like. And so to do that, we can test it by setting everything to fill. Now for the image background, we don't need it to be visible just like with the other one. This is just to avoid any issues. Let me just make it completely invisible. Next, we need an image. And this image is going to be used for our actual visuals. Can we actually see the item? Okay, sorry, so I made a little mistake here. We want the canvas panel to have a padding of 5. And we want the image here, our invisible one, to be -5. Sorry, no. We want it to be, yeah, -5, -5, -5, -5, because we want it to extend outwards. We just want to keep the actual image itself within this. So 100, sorry, no. Just fill 0 and 0, and this is the image we will see. So image visual. Let's see. For this one, we don't need it. We don't need it to be a variable. Fine. Then we need to add a text for the actual quantity. Now, for the quantity, we want it to be anchored in the bottom right, and we'll make it black to make it more visible. Set it to 0, 0, and we want it to be 1 on both of the alignments so that it appears like this. We'll set the justification to be to the right so that it builds that way, and we'll put 0, 7 for now, just so we have something to illustrate it. We'll change the font to Roboto Tiny, it's a bit easier to read. And in my case, I set it to 16, so it's a bit smaller, and we'll make you 23 so that you're better adjusted. In addition, what we can do is we can add an outline of 1, sorry, not 14, 1, and we'll make it of color white, so that if the item is a bit darker, we can still actually see it. So next up, let's make all the actual logic in the graph for the item. So on event construct, we're going to set the actual material, and to do that, we need to inform it what it needs. So in that case, we're going to need a key, and we're going to need a item structure. So key is going to be an integer. It's going to be exposed on spawn. Actually, both of them need to be exposed on spawn. Let's do that. And for the item structure, you're going to be of type st inventory. That'll do it for our, actually, we forgot this needs to be variable, otherwise we can't write on it. And so with our structure, we can split it, not that. We can split our item structure here. And with that, for our image visual, we can say set brush but from texture. Okay, so that doesn't work directly. We need to, do that. We need to get our texture, or what do we call it? Image, get image. Our image will go into our texture. And then we need to set our text. So this needs to be to text. And we're going to get our text block and say set text. There we go. And with text, we can also modify this. Sorry, it's connected. We can modify this to say things like we want it to have 0, 0 before, or just 1, 0. So that's what we're going to use here, just 1. So right now it will update visually. We just need to inform it what to look like. So for that, we can actually do that right now before we do the rest. In our UMG grid, we can say, let me just open it here. We can do a bit of our add item to grid. So for that, we want to create widget, and the widget we want to make is our item. And now we have our key, we have our value, so we can set it up. And for now, we don't have some of the stuff set up yet, but for now we'll do with this. We want our grid. We want to add child to grid right here. And we're going to use our macro to plug in the rows and the columns. And for the child count, we have the key, because that's the location it is in our actual inventory. And for the max, we have the same actual max. Go. And this time, one thing we need to specifically do here is we need to set the layer, because if we don't set the layer, it will end up behind the actual empty slots, which is useless. We can't use that. Now, for the first time, we can add to our inventory grid here. So we're going to call add, and we're going to tell it, well, to add our key, not that one, this key, sorry. We're going to add our key, and we're going to add the actual variable here, or our new, what's it called, our new item that we just added to, or at least added visually. It's always been there. Here we go. Just align these up once again. And after this, we can call inventory item added, and we're taking the key, and we're taking the structure. Sorry, get value. Let's align these. Go. So with that, we're done. And now normally, if we play this currently, press tab, nothing happens. We don't have any items. But if we pick up a cube here, we have our cube that appears. Now currently we can't do anything with it, and if we pick this one up, we have 2, and now we can actually pick everything up because we set it to max. Now there's a bit of an issue because they all have the same icon currently, so we'll have to change that in a second. but it all works as intended. The items get split and they all appear individually. So next up we need to, well, we'll do the other functions here for now. Let's do that, yeah. So we'll do the item split stack next. So if item split stack, first we want to check whether we allow duplicates. Because if duplicates are not allowed, we don't want to do this. So we simply return, sorry. So if duplicates are not allowed, we don't do this. If they are allowed, we do a for loop. And we're going to go through and find the next closest location in the grid that we can actually use. So grid size -1 again. So using this. Go. Just give it a bit more, just a bit of space. Go. So the first thing we want to do is we're going to look if our grid inventory uses one of these items. So we'll find and see if it contains it. If it does not contain it, so we'll use the not boolean here, then that means that there is a slot available and we can spawn it right here. Now in this case, we don't have to go through the whole thing because we're specifically looking to split. So we want to cut it right where it is. We don't want to wait until the end, like in the case where we were trying to add an item. So we want to reroute our index here because we're going to be using it a bit later. Reroute, there we go. And so if this is true, we want to get a reference to our, what did we call the input? We call the input item split. So get item split. And with it, we want to get our structure. And we want to call break the structure. And what we want to do here is we want to make sure that we split it correctly. So we want to divide it by 2. So let me just do that here. So dividing it by 2 will give us what we'll call L new quantity. Go plug that here. And we also want to save the old one separately. So we're going to say minus new quantity here. And this new quantity is going to give us our old quantity. So L minus old quantity. Now, sorry if this is not very visible, let me just move that. For the old one, we're specifically using the original quality minus the new one that we got from the division. So in the case for the item split, we're going to tell it, well, hey, you're updated now. Well, actually, we don't have that function yet. So we'll leave this here for now. What we're going to do is we're going to update its quantity. And in the other case, we need to use our index here to say add item to grid, like this. And what we'll be using is the key will be this here. But for the structure, we'll be splitting this and we'll say new quantity. So get that here. Sorry, get the new quantity and attach it. And for the actual data asset, we'll use the same one as here because it's the same item. So we can just hide unconnected. There we go. So put a return value here. And let's just do this before I forget because we do need to call something here. So inside of our item, let me just save this. Inside of our actual item itself, we need a function called update quantity. And what update quantity does is it takes the new quantity that we give it here with an index or an integer, sorry, new quantity int. And what we'll do is we'll first update our structure. We'll say set members and we'll say the quantity, there we go, to our new quantity. Nice, 2 up, move them here. And obviously we need to update our text, so we're going to say set text, and we're going to straight away plug that in like this. And one other thing we need to do, which we haven't set up yet, but I'm going to do it here, we're going to set visibility to visible. This is because when we move items, we need to be careful of some things. So I'm just going to do that here. So one last thing we need to do for this item to work 100% correctly, we need some more event dispatches again. So the first one we'll need is split stack. which is going to call the function that we made earlier, or that we modified earlier, sorry. Then we need item removed, and finally quantity modified. So for for quantity modified, we're going to call it here actually. And what we need is we need a key and we need a structure. As usual, we're going to call st_inventory, go, and we'll just connect these right here because we modified them a second ago, so we can just plug them in straight away. For split stack, we need a reference to self, so we'll just call it not celt, self. Sorry, so that doesn't work. This widget, we'll call it then. This widget of type umg item. This. And for item removed, just like all the other item removed, we just need the actual integer, which is the key. Compile and save. So now we can close this. And actually, sorry, in our inventory grid, we can now say update quantity, and we take in the old quantity here. Go, plug that in, compile and save. So with our new functions that our new event dispatch that we created, we need to go back to our grid. And when we add the items, we need to actually set all those up. So let's just do that right away. So once again, in our inventory grid, we go to our add to item, and we're going to set up our 3 events. So get a reference from our item widget, say bind, bind event, we'll say split first, and this should be once again quite easy because we say create, and we already have a reference to our item split stack right here. Then we'll do the same thing for the other ones. So let me just make it easy to read like this, detach that like this, and we'll need one more right here. Here we're going to bind event added, I think that's what it's called. No, removed. Sorry, we'll start with removed. Get our event, create event, and we should have item removed here as well. Finally, last one. Let's see, bind event, quantity modified. Attach you right here. Let's just move this to the side again, like that, and we will call create event again, and we have our item quantity modified here that we need. Compile and save, and with that we are done with our item split. For our removed, we can do that now as well. So for remove, it's pretty simple. We're going to call our grid inventory here. We're going to say remove. We're going to remove the key, not that key, this key at the bottom. There we go, and we'll call our actual item inventory removed, sorry, not the added, the removed one, call it, and plug our key into it here. Compile and save. Next is the quantity modified, which we already did, which is very simple, doesn't change. And with that, we have finished our inventory grid. We don't need to touch it anymore. We're completely finished with that on the grid. Next is going to be the actual moving part, which gets a bit more complicated for those who don't know how drag and drop operations work. So we're going to go through that a bit. So back inside of our item right here, we're going to need quite a few more functions. The first one we'll need, or at least we'll make, is remove item. And this is very simple. It's going to be our item removed called here. It's going to be a key that we have right here. And we're simply going to call that and say remove from parent. And this will just destroy this item once we no longer need it. So we can close that, close this. Let me just double check. Yeah, that should be good. So now we're going to move on to a few other things. So to make things tidier, we're going to make some getter functions, which is going to be get max stack. It's going to be a pure. It's going to return an integer. So return value. And very simply, get our item structure, break item structure, and get from our data asset max stack. right here, plug it all in, and there we go. We're going to do a duplicate of this, which is going to be called get quantity. And this is going to be the same thing, except replace return value with just the quantity. And one last one, which is going to be get data asset, which will just return the data asset instead. So remove our return value, we don't need it. Now these three functions, we're just going to put them in a category we'll call getters, because that's exactly what they're for, that's what they're used for. We're going to get, there we go, and there we go. Because the next functions are going to be the mouse operations, let's say. So what will allow us to call our splitters, which will allow us to call our drag and drop, which we're going to be making. So in our overrides, we're looking for on mouse, sorry, is that correct? On mouse button, and we're looking for down. So this is the result you'll get right here. And we're going to be using a few options here, because this is the item itself. So we want to drag from our mouse event, is mouse button down. And what this will do is it will allow us to check if a specific key is down. And the key we're looking for is, we're going to start with right click. If right click is down, we'll add a branch. We're going to tell it, well, hey, we want to split this stack. So to do that, we need a branch, and we need to check first if we can do that. And to check that, we want to split our item structure and check if quantity is different from 1. Because if it's equal to 1, then we can't really split it, can we? Because it'll just make an infinite amount of them. So if we do that, we call split stack here because we succeeded. The widget is, well, self. So get a reference here to self. And we connect it to the return. Now for the return value, we need to make sure in pretty much every case that we add the handled tag, because if we don't do that, it'll consider like how currently if we press tab, we can drag the mouse to move. If we don't handle it, that's what will happen when we click anywhere, and we don't want that to happen. So here we handle it. If this is not the case, we still handle it. Even if we don't do anything, we handle it. On the other hand here, if this is false, we'll copy our mouse down, add another branch. And for the return value, what we'll do is for the input here, because this doesn't work alone, we need to call our mouse event, because it's like any other parameter, we can call it like this. On false, we'll return handled. It means that we clicked with something else on the mouse that we don't want to register. On the other hand, if this does work, if we do click, and this time on left mouse, sorry, instead of right, we want to drag the item. So we'll call detect drag if pressed. And we're going to use the same key here, left click. And we will, this time for the return, we're going to connect this directly. And what this will do, if we call detect drag if pressed, is it's going to call another function. And so that's what we're going to get here. It's called on drag detected. So for this here, and just to check if it's working, we will do a print here, just so we can see that it's functioning correctly. So we need to have an item, obviously, because we're telling it to do it on item. So we'll pick that item up, it will appear, and if we drag it, if we just click, it doesn't do anything. If we hold it and move, then it will consider a drag. So it works as intended, we're getting our print correctly, we're calling this function. So on drag detected, we need to do something very simple. We need to make sure, because this is something that I realized beforehand, so you might not even notice this if you don't do it, if you don't test it. We need to set visibility of the actual entire widget to be non-hit testable. Now, the reason for this, and I'm not sure why, is if I were to drag an item from one slot to another that's right next to it, it would consider for some reason that I was trying to drop it on the same item. For some reason, it was blocking itself, and I have no clue why, so we just make it invisible so that doesn't happen. For the return here, what we need is we need to say create a drag and drop operation. Now, by default, Unreal already has a drag and drop operation, but if you want, you can go into blueprints and create a drag and drop operation yourself. Now, in our case, we don't need that. If you need to transfer more information or do more actions while dragging and dropping, then you can create your own and modify it however you see fit. But that's not what we're going to be doing today. So for the create drag and drop operation, we want to set the payload. So this is the information that we're transferring to self, but we're also going to set the default drag and drop visual to self as well. We could create a new widget just for that, but there's no real purpose because the item never changes. There's no specific change we want for this, so we won't do that. With that, we're finished with our drag detected, and now normally if we go and play, if we pick an item up, we can drag it across. Now if we release it, nothing happens, it doesn't delete, and it doesn't reset it here, which is what we're going to be setting up now, because currently now it's not clickable anymore because it's gone. So we need to fix that. So back in our item, what we'll first do is we'll make it so that if we drag and drop, we can tell it to drop on an actual item itself. So we're going to do on drop here. And this we won't be able to showcase right away because we need some other things first. Actually, you know what? We're going to be using this later, but we'll make it so that we can move the item around first before we start doing this. So to move an item, we need to be able to tell it where we can drop an item. So to drop an item, we have the on drop function that I just used. So on drop, we do this. And this is the only function we use in the empty slot because, well, that's all we need. We need to just tell it what happens if the player drops it here. So what does happen? So if the player drops an item here, first what we need is from our drag and drop operation, we need to call our payload. So the payload is the information we're transferring. And for this payload, because we plugged in our self, then we're looking for a UMG item specifically. And so with our UMG item, what we want to do is we're going to reroute it here. Now, if we don't have our UMG item for whatever reason, we're going to return that it failed and that we don't want to do anything. We'll just reset the item to where it was before. So what we want to do is we want to check whether the item, is different from, not the item. We want to get the key, not that key, get key, this specific key here. And if this key is different from this key, not equal, then that means that we can drop it here because we don't want to be able to drop it on the same slot because we actually hid our item, so we can't drop it on the item itself. So branch, go here. If we did, then we can call from our here actually. Okay, so one last thing, we need an event dispatcher here once again, which is called item placed. It's just used to say that we dropped the item. It'll take an input like added. So we'll take an input and it will take two inputs, one of the key and one of the inventory structure. So key here and structure here. We'll call it right here, right now. If it's true, then we need to get our current key because it's the same one as the other one. But for the structure, we need to say get structure here because we need to inform it that this is the structure we are transferring. And because of how this works, we're going to call here remove item because we can't just destroy it. Originally, I did plan to just destroy it with a remove from parent, but if we just remove from parent, we don't inform the inventory that that item no longer exists within it. Now, if this fails, we need to set visibility again of our widget that we just picked up to be visible again so that it blocks the target. So return, and this time true, and the same here, needs to be true as well. So that'll do for our on drop, and let's give it a try. So if we go here and pick it up, we can drag items and they currently disappear. Let's just try that again. So I think the reason they're disappearing is because we haven't set anything up to manage with the item placed. So let's just do that first. Oh yeah, okay, so that's right. In the item individual grid, right here where we do our create background, we need to inform it what to do if, well, we have an item dropped on it. But what we need to do here is we're going to say bind event item placed. And the event we're going to use is going to be the add item to grid. So add, we need to say create first. And we're going to select our add item to grid. And that will solve our issue we had a second ago. Normally, if we drag and drop here, it should be doing something. For some reason, it isn't working correctly. So what we'll do is we're going to go into individual slot. We're going to print here to see if we're actually dropping, because that could be the issue. So we are dropping it correctly. We're going in here and we're saying item placed. Let me just double check. We have a key here and we never inform it what the key was, because I forgot to do that at the beginning because we didn't have the actual value. So inside of inventory grid, where we do our create background, make sure that we attach the key from our empty slots. We need to make sure that it's exposed on spawn here, otherwise you can't see it. If it's still not visible, make sure you refresh the node and then it should appear. So now normally if we go and pick this up and drag, it stays there, and normally it stays there as well because we save the information with our event dispatchers. It will stay in the location. Even if we close the widget and open it, pick a new item up, it will fill it because it already knows that that exists, but it will put the new one here because that's the first slot available. And if we go and let's say pick another item up, same thing. Obviously we can't drop them on top of each other because it knows that, but we haven't told it how to react to that yet. So with that, we finished our item slot. This should be 100% done. We have nothing left to do in here, so we can close our slots. Next, what we need to do is we need to inform how our item should react if an item is dropped on top of it. Actually, one thing we could do first, if we right click, we create a new item here. We split it in half, we do the same here, and it's saved as it should be. We can do it all the way until there's one left and then it doesn't do anything anymore. It'll stay like that. So our splitting works as well. Let's move on to telling it what to do if an item is dropped on top of another item. Let's just close that, have it open. So the same trick as before, we want to get the payload. And with the payload, we will cast to item, because that's always not a item, but UMG item. It's always what it's going to be. Or at least it should always be that. If it fails, we return false, and we just reset it. We don't do anything. Now, what we want to do here is we're going to need to promote this to a variable. We'll call this lold item, and the reason for this is because we need to know specifically where the old item is on multiple occasions, so we just save it. Now, first thing we check if the item is different, meaning it's not the same item as self, then in that case we can continue, because if we're trying to drop on the same item, we shouldn't do that, and we'll just return that it failed, so we don't want that. On the other hand, we also need to check if the data asset is the same. So for the data asset, we'll say get data asset, and we can also call this separately here because it's inside of an item. So if these two are equal, then that means that we're using the same data asset, meaning we can continue with what we're doing. Because if it's not the same data asset, then we need to tell it to stop. So we'll do the stop first, because it's a bit easier to process, let's say, or at least easier to finish. So if it's not the same item, then we need to inform the old item to set its visibility to visible again, and then we can return this, that it succeeded, but it didn't do anything. We don't want it to do anything. Next, what we need is we need to check the quantities. So we're going to call once again our old item, and we're going to check if the get quantity, we're going to check if these two are equal. So let's just get this again. Normally if you copy it, it should remove the reference to the target, because we're in the actual parent widget of this function. If not, just simply drag it from here or research again get quantity. Now on true, if the quantity is the same, sorry, no, I got this wrong. If quantity of the, so what we actually want to do, I got that wrong. We want to check whether the quantity and the max stack are equal, meaning if we're a full stack. If we are, then we don't want to do anything because there's no space. So what we'll do is we'll call this again and try to set it visible, so that it can be picked up again to move around. On the other hand, if that's not the case, then we can start doing a bit more. So if the item, now we're going to look for if it's fully consumed or not. So we'll copy these two because we need them again. and we will get a reference to our old item, and we're going to check if the old item has, or how much there is in the old item. So if the current item we're dropping on plus the old item is superior to max stack, that means there'll be some remaining. That means we don't have enough space to store it all. So we'll start with false. So in the case where this isn't true and we can consume the whole other item. In that case, what we want to do is we will say update quantity of self, because we're dropping it on this item, and we'll say to add these two to the quantity, and that will mostly solve the issue. We just need to now tell the old item to remove item because we no longer need it, so we need to inform the actual grid itself and the inventory that that's the case. So we return true and we will be done with the false. On the true, we pretty much do the same thing, but we just need to tell it to not destroy but update both. So what we'll do is we'll say update quantity for self, and for update quantity we're going to simply set it to max stack, because we have more than we can take. The current one automatically gets maxed out and the rest goes back to where it was. So for old item we also update quantity, but we actually need to do a bit of math here and we return true. Sorry, just add that first. So if this happens, we need our get old quantity. We actually just copy the two here. There we go. Let's just get that. We add our current quantity to our old quantity and we subtract the max stack. And this is what will be set to our new one. So with that, now we deal with items being dropped on top of each other as well. And that should be the last thing we need. No, we actually don't have anything to drop our items yet, so we'll do that as well. So right now, if we have this, we can not drop it because it's full. But if we split that, we can drop 70 on top. It updates, it remembers. If we close it, it still knows. If we move that to the side, it knows it as well. If we drop it here, been an issue, that doesn't work. Normally that should have called our logic here. Let's see if it does do that. Okay, so the reason is because I actually made a mistake here. We need to do this the other way around. It needs to be done this way, because otherwise we are setting the actual new variable. So here we're getting get quantity locally, but we've already modified it so it doesn't know how to deal with it. So, well, it doesn't know how to deal with it, it just does it in the wrong way. So we just invert the order and that should fix the issue. If we go like this, if we split that, we have a 50 here. If we drop 70, this will give us 20 here, 100 there. If we drop it again, it doesn't work. Close it, saves it as well. So that's how that's done. So most of the functionality does work. Maybe to make things easier, what we'll do is we'll just modify our items to make them different in appearance. So we'll just change U to icon red. We'll change the cylinder to, let's just take the analog. And the sphere, we'll change it to the actual Android. Why not? And so now if we play, we can pick everything up because we have enough space. We have our 5 different icons. We can split them, add them together. If I drop U on U, it doesn't work. Drop 50 there, it doesn't work. U can't be added. If I split U, you appear there. Let's make a bit of space. If we split this, it will appear there because it knows that's where it is. And I think that's everything. If we split U there, it works as well. Let's say 75 plus 20, 95. If we add here, it becomes 20, that becomes 100. And that pretty much does it. If we close, it's all saved and we can close that. The last thing we need to do is the drop operation. And to do that, we actually use the inventory instead directly. So what you can do instead, now this is optional, you don't have to do this. In the inventory grid or in the inventory right now, I'm going to create another drop operation. But what you could do as well is put this drop operation completely elsewhere. Have it be a different widget. For instance, just create a new one for specifically dropping. Then you can place it wherever you want and it will automatically trigger a drop for you. So to do this drop, there's one thing we need to change, I think, in our designer, is we need to modify the blur backgrounds to be visible. Currently, right now, it's not. You can click through it, it doesn't matter. We need it to be visible so that if we drop it here, it detects the actual image, or the actual object, sorry. So on drop, this one is really, really simple. We want to do the same thing. We want to get payload. We're going to cast to UMG item. Plug it in here, sorry. And with that, we want to simply, first we need to save our structure here. So item, we want to promote this, sorry. We want to get structure. And we want to save the item. So promote to local variable. We'll call it L structure temp. We only need it for a few seconds, if even that. And what we want to do is we want to then remove item, because that's what we need to do. It needs to disappear once we do this. But we also need to say item dropped. So we want to call item dropped. Oh, and because we already dispatched this to the actual item itself, to the actual widget, sorry, not widget, what am I talking about? To the actual AC inventory with our item dropped, and we've already made the functionality, it will drop it by itself. So normally this is done. That's all we need to do here. We can compile and let's play it. So if I go and drag out 20 here, it appears in front, pick it up again, still 20. Let's go and drop the 20 here and we will split this. And it will add itself to the first one. So that's the first one we have. And that does the trick. That's everything that we were supposed to cover. We can drop items, we can pick them up, we can split them, we can drag and drop. We can't drag them on top of each other. This. And we can move them anywhere we need. And if we split, it automatically goes to the top or the closest place it can find. So thank you for watching. Hope you enjoyed. For those who were following with the Satisfactory tutorial, I hope this helped. If not, I'll probably do a quick intro in the next video where we actually go over setting it up with what we already have. So thank you for watching. I will see you in the next video.